Hey guys, I'm going to be showing you some calculus practice problems. These are from chapter 2 of a calculus 1 book, and it's about limits. So I'm going to be doing this first question for you. We're going to start off with this limit by getting a common denominator for the top two terms of 1 over 2 plus x. Okay, so minus 1/2. We get a common denominator for that by multiplying it by 1 plus x over 2 over 1 plus x over 2, and that's still all divided by x. So simplifying a little more, it's equal to the limit as x goes to 0 of the top term is all over 2 plus x, and it's going to be 1 minus x over 2, and that's all divided by x or times 1 over x. Okay, so that 1 minus 1 cancels off, and it's negative x over 2 over x times 2 plus x. So that simplifies to the limit as x goes to 0 of negative x over 2 over x times 2 plus x, which is equal to, we could take that negative 1/2 off from the top, or that 1/2 for that matter, and bring it to the bottom. Then we have negative x over 2x times 2 plus x, and those x's just cancel off with the top and the bottom. And we have that this is just equal to the limit of negative 1 over 2 times 2 plus x as x goes to 0. We could just plug in 0 for this. And we get this is equal to negative 1/4. That's the answer to this limit. Okay, now this is question 2. It's the limit as x goes to 0 of x times cosecant x plus 1 over x times cosecant x. So we can rewrite cosecant x as 1 over sine x and make this the limit as x goes to 0 of x sine x plus 1 over x sine x. Okay, and we'll do the same thing we did on this problem that we did with the last problem. And we'll get a common denominator for the top two terms. So 1 is equal to sine x over sine x. So we just expand this fraction bar and we put plus sine x. And we see we have a sine x on the top and a sine x on the bottom. Those are going to cancel each other off. And we get that this is equal to the limit as x goes to 0 of x plus sine x over x. And we can simplify this a little more. We're writing as the limit x goes to 0 of x over x plus sine x over x. And you should know, you should have this limit memorized, that the limit of x of sine x over x is just equal to 1, and x over x is obviously just equal to 1 as well. So it's 1 plus 1, which is going to be equal to 2. Okay, another question here. Not much work to write on this question, but it's the limit as x goes to infinity of x plus sine x over x plus cosine x. And we know that that sine x and cosine x just oscillate between negative 1 and never get any bigger than that. It'll just be moving, as x goes to infinity, it'll just be oscillating between negative 1 and 1. And as x goes to infinity, that'll go to infinity, and as x on the bottom goes to infinity, that'll also go to infinity. So those two are the dominant terms in this, and those two are going to grow at the same rate. So the top and bottom essentially just grows at the same rate. So this is just going to be 1. It's kind of just, you could just think of it as x over x, since x is the biggest term on the top and bottom, and that's just 1. Okay, so for this question, it asks us to find a value of k that makes function continuous at x equals 3. Okay, so to do this, we have to take the limit as x goes to 3 of x squared plus 2x minus 15 over x minus 3. So we could rewrite this a little better by factoring that top. So we're going to think what multiplies a negative 15 adds to 2. So it's going to be x plus 5 times x minus 3. X minus 3's cancel off. And we have just a limit x goes to 3 of x plus 5. So that's just going to be 5 plus 3, which is equal to 8. So k is equal to 8. Okay, we have a word problem here. It says the number of bears in a federal wildlife reserve is given by this function where t is years, and it's asking us to find p of 0. And we see the answers in here. It's 25. And that's just going to happen from plugging 0 in for t and then plugging into the calculator. You're allowed to use a calculator in this question. And for finding the limit as t goes to infinity of this function, it's basically just letting e go to this whole 7e term go to 0, and it's just 200 over 1, because as e to the negative of something, as t goes to infinity, here it's basically like 1 over infinity, which just goes to 0. So this whole term right there just essentially goes to 0 in that, and it ends up being 200. And a possible interpretation of why, as the number of years goes to infinity, why it goes to 200, is because there has to be some factor preventing this population from growing past 200. Another thing you could say is that the population has reached its carrying capacity. Alright, so that's the problems from this chapter. Thank you guys. Hopefully this helped.